So the next question is, given KSP of AgI, that is silver iodide, 8.5 into 10 to the power minus 17, the solubility of AgI in a 0.1 molar potassium iodide solution is. AgI is AB type of a salt. For AB type of a salt, KSP, if you apply the formula x raised to x, y raised to y, s raised to x plus y, then KSP will be equal to s square, so s will be equal to root of KSP. We would have used this formula if 0.1 molar potassium iodide was not mentioned. They have mentioned 0.1 molar potassium iodide. Potassium iodide, iodide is a common ion. In presence of a common ion, the solubility decreases. Hence, we need to solve this problem by a different method. Now, if potassium iodide was not mentioned, then KSP would have been equal to S square or S would have been equal to KSP. This would have been the formula that we have applied if 0.1 molar potassium iodide was not mentioned. Since they have given the potassium iodide, so how to solve the problem? AgI dissociates to give 1 Ag plus and 1 iodide ion. So KSP is equal to concentration of Ag plus into concentration of iodide ion. We need to calculate the solubility of AgI. Let us consider the solubility of AgI be S mole per liter. If silver iodide solubility is S mole per liter, it produces S mole of Ag plus and S mole of iodide ion. So the concentration of Ag plus will be S into concentration of iodide ion will be S from AgI, plus the solution contains 0.1 molar potassium iodide. So potassium iodide dissociates to give K plus and I minus. If you take 0.1 molar potassium iodide, you get 0.1 molar iodide ion. Hence, the concentration of iodide ion will be S plus 0.1. Why it is S plus 0.1? Because S that is obtained from the dissociation of AgI and 0.1 due to the presence of potassium iodide. If potassium iodide was not mentioned, then 0.1 would have not appeared in the equation, then KSP would have been equal to S square. So since potassium iodide is given, KSP is equal to S into S plus 0.1. Now, since the solubility is very low, solubility of a salt is very low, so hence we can take S plus 0.1 nearly equal to 0.1 because the solubility will be very low. Hence the equation KSP reduces to KSP is equal to S into 0.1. Now, so S is equal to KSP divided by 0.1, that is KSP value given is 8.5 into 10 to the power minus 17 divided by 0.1, that is 8.5 into 10 to the power minus 17 into 10 to the power minus 1, if it goes it becomes 10 to the power 1, so that will be equal to 8.5 into 10 to the power minus 16. Hence option B is the right answer. Students, the next question is solubility of AgCl in water 0.01 molar calcium chloride, 0.01 molar NaCl and 0.05 molar AgNO3 are S1, S2, S3 and S4 respectively. Then the relations: option A, S1 greater than S2 greater than S3, S3 greater than S4. Option B, S1 greater than S3 greater than S2 greater than S4. Option C, S1 greater than S2 that is equal to S3 that is greater than S4. Option D, S1 greater than S3 greater than S4 greater than S2. Now, solubility depends upon the common ions that are present. In presence of a common ion, the solubility decreases. We have solved a problem, last problem that we have solved in presence of common ion where the solubility was low. So in presence of a common ion, the solubility decreases. As the concentration of the common ion goes on increasing, the solubility of that particular electrolyte or a salt decreases. Now let us consider the solubility of AgCl. So solubility of AgCl they have given in water in 0.01 molar calcium chloride, 0.01 molar NaCl, 0.05 molar AgNO3. So solubility in water is represented by S1, solubility in calcium chloride as S2, NaCl as S3 and AgNO3 as S4. So as the concentration of the common ion increases, the solubility of AgCl decreases. Water does not have any common ion as compared to AgCl. If you compare AgCl and calcium chloride has chloride ion which is common to AgCl. So one calcium chloride will give you 2 chloride ions. So the concentration of chloride ions produced will be equal to 2 into 0.1. NaCl produces 1 Cl, hence the concentration of Cl minus, that is common ion, is equal to 0.01. Whereas in AgNO3 the common ion is Ag plus, and 1 AgNO3 will give you 1 Ag plus, so the concentration of Ag plus ion is 0.05 molar. Hence if you examine all the 4 options, water does not have any common ion, so hence the solubility of AgCl in water will be maximum. Now next comes calcium chloride, sodium chloride and AgNO3. In AgNO3 the concentration of common ion is more, so in AgNO3 maximum common ion effect is observed, so the least solubility is observed in AgNO3. So if you go according to the order, so maximum soluble will be, it will be maximum soluble in water, next NaCl, next calcium chloride and next AgNO3. So it will be S1 solubility in water, S1 is greater than S3 because next common ion least, next comes S2 and next comes S4. So option B is the right answer.
ಡಿಯರ್ ಫ್ರೆಂಡ್ಸ್, ನೀವು ದಿವಿಗೆ ಯೂಟ್ಯೂಬ್ ಚಾನಲ್ಗೆ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿ, ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸ್ಗೂ ಹೇಳಿ, ಇದೇ ಥರ ನೂರಾರು ವೀಡಿಯೋಸನ್ನು ಫ್ರೀಯಾಗಿ ನೋಡಿ.